You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello everyone, thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this. Hey everybody, welcome again to the show. I've been teaching about birds for many years now, and one of the topics
You're doing another bird?
One of the topics I'm fascinated by is bird migration. So I want to go through a little bit of some of the strange ways that birds migrate. The ability to migrate and wayfind seems pretty strange to us, especially if you're the type of person that gets lost in a mall or has like zero sense of direction. There's a number of strategies birds use. Some are obvious, some not so obvious, and some are even strange. So first, some of the normal stuff, like you'd expect. They use landmarks, just like you might remember the way to a friend's house by knowing that you follow a certain road until you get to the grocery store, then you turn and drive to the ice cream shop, and then it's the fourth on the left. Well, birds basically do the same thing. They read the landscape and simply remember the way. They do need to learn the way. Some of them do need to learn the way. And many birds learn the migration route from their parents. Whooping cranes are a good example of birds that do this. And if you've ever seen footage of people from the International Crane Foundation leading cranes south behind an ultralight aircraft, that's because they literally had to teach these hand-raised chicks where to migrate to, or they would not have found the way. So kind of like a subcategory of following landmarks is like these bird flyways. So they exist all over the world. The North American ones are the ones I'm most familiar with. But there's like the Atlantic flyaway, the Pacific flyaway, the Mississippi flyaway, etc. Birds are essentially following long landmarks like rivers and coasts to help to get them to their destination. That's sort of like on the big picture, finding their way. Now, there's other ways to find your way. And I should point out that we think birds use multiple methods to find their way. And not every species uses the same methods. Another popular method is to use the sun. Probably more specifically the location of the sun at sunset to know what direction to fly in general, because many birds migrate at night when it's cooler and safer from predators to fly. So they wait until sunset and then they head out. And so knowing where the sun sets gives them a general, bearing to start off with. Obviously not heading toward the sunset, but find their bearing from where it went down. Now, research suggests they also use the moon, which that really starts to kind of blow my mind because the moon is not always visible, and it also doesn't rise and set at the same time interval as the sun, right? It's not as a regular of a thing. When the moon rises has a lot to do with the phase of the moon, so the fact that the birds can use that is pretty amazing. I actually don't know if it's more that they're using that to find their way or using it to like hold a bearing. As they're flying, they're using it as a reference point in the sky more than just like, I don't know if they're actually using it to find what direction to fly, right? So it's a lot of factors coming together. So the method I want to focus on today is for migration is one of my absolute favorites because it combines two of my great loves, birds and astronomy. I talked about astronomy last week. I'm going to put the two together here. So they also combine those two things with something else that I find really fascinating, which is really, really well-designed experiments. Okay, so people suspected that birds might be using the stars to navigate, but there's always been a problem. How do you know, right? You can't ask a bird, and there's way too many independent variables. I mean, the stars are out at night, and birds migrate at night, and yes, humans use stars for navigation, but, there could be other explanations as well. So you could never really
And how do you test for that?
Exactly. How do you test for that?
I would love to ask a bird, but you can't blot out the stars to a bird.
Exactly. So we know that birds use more than one method to migrate. So how do we isolate and test just one of them at a time so we know that they aren't using something that maybe we haven't even thought of, right? So the first people to really put this to the test were Edgar Gustav Franz Sauer and Eleanor Sauer, who were mighty duo. And back in the 1950s, they did experiments with birds that could see only the night sky as their migration cue. They did the experiments outdoors, but to eliminate all variables, they eventually did do experiments in a planetarium. Yeah, and what they figured out was that the birds would only attempt to migrate when they could see the stars. So if they would turn the stars on in the planetarium, the birds would try to migrate. If they were off, they wouldn't try to migrate. So it's pretty
brilliant.
clear they were looking at the stars, right? I love that. Great design. So that was a good
Cool.
that was a good start, but it didn't really tell us how they use the stars, just that they do use the stars. So the question of how puzzled another researcher, Stephen Emlyn, who is currently a Cornell Emeritus Professor of Neurobiology and Behavior. But back in the 1960s, he was a grad student at the University of Michigan, and he conducted a series of experiments that showed once and for all exactly how birds use stars to migrate. And he did this in the, once again, planetarium. It was the Longway Planetarium in Flint, Michigan. So Emlyn used one of my favorite birds, the indigo bunting, for his experiments. And what he did was he placed the birds into cages that were essentially white paper cones with an ink pad at the bottom. And when the birds tried to scramble up the sides of this cone to take flight,
Hang on a
they
second.
left...
Were the cones oriented like vertically? Or...
So opening toward the top. Like
Okay.
the big end of the cone was up and they were down at the bottom of the
Gotcha.
cone. Okay. So when the birds would try to take flight, they would scramble up the side of the cone, or the inside of the cone, and leave these tiny little birdie footprints on the cones so he could see what direction they were trying to fly. So not just were they trying to fly, but what direction were they trying to fly. And what he found out when he would look at the cones is they were heading south, and they must have been doing it by looking at the stars in the planetarium. Now, tellingly, if he spun the projector around so the stars were not lined up with the true stars outside, the birds would try to fly south according to what they saw in the fake sky above them and not according to what direction was south outside. So we know it's not like they're sensing, just sensing direction.
Magnetic.
The only cue was the stars, and no matter which direction he would make the planetarium appear to be south, boom, the birds would try to go that way. All right, so...
so cool.
Like, how did the birds know, though? Right?
Yeah.
How do they know which way was south? Because there's lots of different stars up there in the sky, and the challenge was
which star
could he figure it out?
So did he start
earlier
taking stars away?
Yep. So earlier researchers had speculated
so
that the
cool.
birds remembered which stars were in which part of the sky at specific times of the night, and that compared them to an internal clock. That seems really kind of far-fetched to me, but Emlyn eliminated that hypothesis by showing that they could orient themselves correctly even when the sky being shown was wrong or did not match the actual time it was outside. Okay. So they're not using any kind of internal clock to know where the things should be. They were simply just doing dead reckoning, looking at the sky, assessing the current state of the sky, and gleaning direction from it. So what he did is exactly what you thought. He started to cover over, get probably tape and
Sounds
card
like
stock
scraps
or
and-
I don't know,
yes.
probably picturing construction paper or something, and started taping over the constellation on the projector to see if they were following certain patterns in the sky. So he'd block out different random constellations, and he might black out a whole constellation, and the birds did not seem to care one bit. They still went south. So he's like, okay, that seems weird, but something did screw them up and really make it so they could not find south. Was if he eliminated any of the stars that were near the North Star. So getting rid of the North Star did not matter. But if you got rid of too many stars near the North Star, that would mess them up. Now, many of us scarcely notice that the stars in the night sky all seem to spin around the North Star. If you think about it, if you're at the North Pole and you look straight up, you'd see the North Star. And it would not move, essentially, and all the stars would rotate around. Here where we are in Minnesota, we're 45 degrees north. The North Star is about 45 degrees up in the night sky, and all the stars still seem to rotate around it at night. The birds have figured this out, and they notice that some stars move more than others, and they focus in on the part of the sky that does not seem to rotate. And in doing so, they know which way is north, and then they can either go north or go the opposite of it, go south, depending on the season. So Emlyn, I love this. He was so curious about this. He went so far as to alter the planetarium so that Betelgeuse was the star that everything rotated around. And then check out this dedication. He then hand-raised birds completely in the planetarium so that the only sky they knew was the sky in the planetarium. Okay? And amazingly, these birds learned to follow Betelgeuse
those poor birds
instead of the North Star.
Whoa.
Because they, again, had some sort of innate, they are born knowing, they're not born knowing like which star to follow. They're born with this sense of like, I need to follow the part of the sky that isn't rotating.
That makes so much more sense.
So cool. So cool.
Okay, here's a really important question though.
Yeah.
Didn't like anybody need to use the planetarium in this whole time?
He must have gotten so much leeway. I don't know. I mean, what it was he got permission to use it at night. So like the last show might be like a 10 o'clock at night show or something like that. And then he was up all night and had totally free reign with the planetarium as long as he put it back how it had to be by the shows the next morning. So really super cool. These amazing experiments have taught us a lot about how birds use the sky to migrate, but there still are a lot of unanswered questions. As a side note, as an amateur astronomer, I really hate light pollution, but imagine you're a bird trying to migrate and you can't see any stars at night. We know they use multiple methods to find their way, but I would just ask our listeners to please consider turning off outdoor lights at night, especially during migration. Because it's so important to helping these birds learn how to migrate. And so on today's episode, I only covered using landmarks and memory and the sun and the moon and then, of course, stars. But there's a whole bunch of other methods birds use. And spoiler alert, I will be covering them in some future episodes.
I can't wait.
That's so exciting.
Yeah, it should be fun.
I'm so excited.
They're pretty strange. So we're going to go to the break. After the break is going to be Rachel, who's got something exciting for us. Can't wait to hear it. If you're listening to this podcast, you are at least a little strange by nature, just like us. Why not make it official? We're happy to announce the launching of our Patreon program, and it's called The Society of Strange. You can join today.
You may have noticed we've been experimenting with not having ads on the show lately, and it has been great. But while we're not doing this for the money, doing a podcast like this can get expensive.
We have web hosting fees, there's audio hosting fees, equipment fees. It all really adds up. By joining the Society of Strange, you can help us sustain the show and get some perks as well.
All Society of Strange members get one of our swanky new water bottle stickers, and at higher levels of support you can get secret bonus content and even our studio voicemail number.
Oh, yes, excellent. You can check it all out at patreon.com/strangebynature.
All right. Welcome back, everyone.
Thank you.
This week, we're going out to the bottom of the Pacific Ocean. Not the bottom, like Marianas Trench bottom of the Pacific Ocean. We're going to go around
something
California.
aquatic. What a shock.
I know.
Who would have guessed? As I stare down my ocean encyclopedia.
You guys, she's so proud of her ocean encyclopedia.
It's so cool. Oh, I'll also share a picture. It's so fun. So we're in California, Baja, California. We're having a great time. Maybe we're in San Francisco. Let's go swimming. Let's go diving. We get about 10 feet. We can snorkel that. Go down. We're hanging out.
Sounds cold.
We're swimming.
I'm so confused already. Okay.
And excellent.
We're in Baja, California, and we're in San Francisco.
I do want to pause to all of our listeners who are from California and understand that Baja and San Francisco are nowhere near each other.
Also not in the same country.
Also not in the same country. Yeah. But okay.
No.
But go on.
Baja California.
Which is in Mexico.
Yeah, it's in Mexico.
Well, I learned something more today. I apologize to California.
And to Mexico.
The range of this is all up and down the coast of North America, mostly from San Francisco to Baja, Mexico. It's 3 meters. We're having a great old time snorkeling. And lo and behold, in the rocky reef, there is this fish.
Mm-hmm.
Who would have guessed? And it pops out, goes back in. What is that? Is that fish living in a tube? Maybe. They have been found living in plastic tubes, actually. Their scientific name is, their binomial scientific name is Neoclinus blanchardi. Thank you.
Very nice.
Practiced. And listen to it. I would like you both to open the email I sent you.
Oh, no.
Subscribe. Yep.
Holy.
Whoa! Oh, good gracious.
Okay, so the first one looks a little scary, and then you scroll down, it's like a dragon.
This first picture is kind of cute. And the second one looks like...
Yeah. I'm so excited. I can't
It's a
wait
stretch to
tell
call
you
the
what
first one
combination
cute,
is.
Kirk.
Well, okay. Grumpy cute. Kind of a grumpy
Maybe.
cat version of a grumpy fish. And then the second one, do you want me to just describe this for our listeners? Like,
Yeah, you go for it.
okay, I'm not sure how this is even physically possible, but it looks like this fish has opened its mouth, but almost like it's opened it, instead of up and down, like side to side. I'm assuming it has
a
like hinged jaw.
Mouth wings.
Yeah, like mouth wings.
It has mouth wings.
Again, we've used this metaphor or this simile sort of before, but if you're a Stranger Things fan, the Demogorgon's got those little like face flaps that open, kind of like that.
Yeah.
But then there's like almost another mouth inside that with like a purplish blue, essentially tongue hanging out with sharp white teeth up at the top and the bottom. The whole thing is kind of rainbow colored, like it's purple in the middle, and then the mouth flaps on the outside are like green. And then yellow edge.
It's like there's a rim around it. It's red at the top and yellow kind of around the sides and the bottom.
And the colors are the exact colors that are found in like a Crayola watercolor kit. They are what a child would draw if they were describing some sort of monster. This is terrifying and fabulous.
I loved it so much. I had to choose this because of the common name, and then I saw a picture. I'm like, well, I have to do this now.
What's the name?
Also, there are sharp teeth. What was the name again?
The binomial name is Neoclinus blanchardi.
Mm-hmm.
The common name is the Sarcastic Fringehead.
Wait, the Sarcastic Fringehead. That's what they came up with.
That's what they came up with. That's the name of this fish.
I mean, I thought the mouth closed version looked a little grumpy.
I'm not 100% sure why it's called sarcastic. I looked so many places and I couldn't find it. But its common name is Sarcastic Fringehead. So this fish is about 30 centimeters or 12 inches long. So they're not super duper big.
If these were like the size of, I don't know, like a dolphin, no one would ever go in the ocean. Ever.
No, they're not. So these are actually tube blennies, which is a type of fish that hangs out in crevices.
Okay.
it likes to hang out inside of shells and little hiding places that it's found. I said that we may see one in a tube. They have actually been found in like soda cans. Huh. Just hanging out in the soda cans.
Don't drink the soda.
Just chilling in the ocean. Why not? So the biggest thing, mostly scaleless, and they have really long pectoral fins and really reduced pelvic fins, so around the hip where we would, and their swimming motions are super complicated because they're super short and fast dart-like
So
swim.
they're like a sea pug.
Kind of, yeah.
Okay.
They're a very hardy saltwater fish. And the reason why I sent that particular photo, they are able to descend their mouth open like that. The males disjoin or descend their jaw in that super colorful photo I sent. For the mouth wings, the reason why they do that is they're super, super territorial. The males are really aggressively territorial.
So this is a territory display, right?
Yeah. Well,
okay.
Sort of. It gets weirder.
Oh, good.
Because they're the ones that are guarding the eggs, all of the babies. Because they're guarding the babies, they want to make sure they stay nice and safe. But because they are so territorially aggressive, what they'll do is there are two males that are too close together. What they'll do is they will, in order to establish dominance, they will open up those wing-like mouth parts, descend their jaw, and open it. And then they wrestle by pressing their descended mouths and wing parts against each other. So it looks like they're kissing. I'm not joking. That is
Are you being sarcastic?
I wish. So they're having that territorial battle. So eventually they press, and whoever has the biggest mouth establishes dominance.
Of course, that's how it works.
So that's how they figure out who's the largest fish. If their mouth is bigger than the other, then they are more dominant, and they're allowed the territory, and the other fish has to go. But that's one of the strange things about them. There's not a ton known about them. Other than that, they're called Sarcastic Fringehead. Their mouths descend. Scientists thinks that the descending of their mouths, it can actually cause the males to not be able to eat as well. It could cause issues for them, or at least some scientists think so. It could be ineffective because, generally speaking, tube blennies eat plankton and such. There's not much well known about the sarcastic fringehead and what they eat and such. So it can cause some issues in that front. So super small prey.
Oh, okay.
But this species can't suction feed because of how their mouth is oriented and how they open up. So we're not sure how they eat. We know they eat large numbers of squid eggs during the squid spawning season, but otherwise we're not 100% sure how or what they eat. Otherwise, they probably eat a big variety of prey, but we're not sure. They're just fascinating. What little we know is amazing. I mainly wanted to talk about it because it's called a sarcastic fringehead, and his mouth gets really big, and they kiss to establish dominance. It's just so fun. I went down a really bizarre path, so thanks for sticking with me. That's what I got for you this week.
Thanks, Rachel. That was a really great story.
Don't be so sarcastic.
Don't be so sarcastic.
I can't help it. I'm looking at this crazy picture of a sarcastic fish.
Right, after this, it'll be Victoria.
And we're back. All right, here's a scene from a movie. Ooh. A hardworking farmer is out in the fields in the hot sun. They stop to mop their brow, squinting off into the distance. Suddenly they stop, stare harder. The camera shows it. A black cloud is coming closer.
Oh no.
A tremendous buzzing fills the air. The farmer waits a beat, then runs, shouting to the others on the farm to protect the crops. It is a plague of locusts. The locusts are coming.
Oh, wow.
I feel sure that I have seen at least one movie scene like this over the years, although I really cannot come up with the name of the film or films that they were in.
It's
if
pretty
any
common.
of our listeners
Prince
know
of
some,
Egypt.
yeah, add us on social media.
Yes.
But Prince of Egypt. Okay, there we go. Thank you. You knew one. So if you were like me until a few years ago, you probably had heard the term plague of locusts or maybe swarm of locusts, maybe as something somebody said metaphorically or possibly mentioned in the Bible. And you probably knew they were insects, but not exactly what kind of insects. Or possibly, as we mentioned in the episode a few weeks ago on cicadas, you maybe thought they were cicadas, not cicadas.
Maybe. But I also knew that you had talked about it before, so it's probably not.
Right. I mean, if you weren't a listener of this show during that episode, perhaps.
Fair.
But actually, locusts are grasshoppers.
What?
They're just grasshoppers.
Right. Okay.
But with a twist.
Yeah, there's a twist.
Yeah, so not every grasshopper is a locust, but every locust is a grasshopper.
Okay.
And there are locust species on every continent except Antarctica, although the main one that used to swarm in North America went extinct in the early 20th century. But anyway, locusts are just a swarming phase of a type of grasshopper that is normally solitary. So they actually call the different phases solitary and gregarious. And these grasshoppers just like get...
I have those phases
Yeah.
too.
Yeah, me too.
Don't we all?
I think we all just went through a really solitary phase.
Oh.
That was so sad.
Yeah.
Not by choice.
No, not by choice.
So go on with your story about plagues.
Yeah. So they can be triggered to swarm. There are a few different things that go into it. So broadly speaking, the swarms will tend to form when drought conditions are followed by a lot of new plant growth. That is, things for them to eat. So these solitary grasshoppers start to multiply more, and as they actually interact with each other and kind of bump into each other, they actually trigger hormonal changes caused by an increase in serotonin, which you may have heard of. It's a neurotransmitter that's in humans and, in fact, across the entire animal kingdom, which is pretty darn cool.
That is pretty sweet.
So the hormonal changes change their behavior, cause them to like to get close to each other and start to form these giant groups, but they also actually change their appearance.
What?
So
Yeah, cool.
yeah. So the desert locust, which is kind of one of the best known of these type of locust grasshoppers. So in the solitary phase, it's kind of a green or a brown or a dull yellow. In the gregarious phase, they're this flashy bright yellow and black, or a pink when they're a nymph. So it's basically as if
I'm just I gotta go. I'm picturing like a nightclub.
Totally.
Where like they're all dressed up fancy, and as everyone's bumping into each other, the hormones start going. And
completely. Yeah, it's like
Yeah.
there were a bunch of desert hermits, and they met up with some other desert hermits, and suddenly decided they want to be
distance they hear
city dwelling
like,
party animals.
Hey, let's start bumping into each other and get our hormones going, and
start
put
wearing
fancy
those
clothes on.
latest fashions instead of your dusty hermit rags.
Right.
So basically,
Just rip off the dusty hermit rags and it's fabulous.
Exactly.
Also a good metaphor for 2020. Okay.
So they change their appearance. They get longer wings. They breed a lot more readily now. And instead of being these solitary hermit-like local short-distance flyers, there are now these massive, absolutely massive storms that start to roam across the landscape. And they eat pretty much every bit of plant matter in their path. So as you can imagine, this is a huge problem for farmers. And locust plagues have caused many famines in the past. These swarms can be just immense. So for desert locusts, which live in Africa, the Middle East, and South Asia, there was a plague from 1966 to 1969 where they measured, and the number of locusts started out around 2 billion and increased to 30 billion over 2 generations.
Oh, man.
And so actually, as the swarm goes along, it gets larger in terms of the number of insects, but more concentrated. So the insects bunch up closer. And so in this 1966 to 69 plague, the area that they covered started out as more than 100,000 square kilometers. That's 39,000 square miles. And then reduced down to 5,000 square kilometers, but with, from like the 2 billion to the 30 billion.
Mm-hmm.
So just,
oh man.
Yeah. And these plagues have been known from biblical times up to the present. And in fact, there was a plague that ravaged the Horn of Africa, the Arabian Peninsula, and part of the Indian subcontinent in 2019, 2020. That was spurred by wetter conditions. So
did hear about that.
Yeah, it's causing more food insecurity in an area that's already food insecure. It's very unfortunate.
Yeah.
Scientists think that this behavior is possibly an evolutionary response to boom-bust weather cycles that tend to happen in this part of the world. So they basically take advantage of the intermittent rainfall cycles there.
Well, and like deserts in general.
Yeah.
It's the plants do the exact same thing.
Yeah, exactly. And basically the swarms will end when a longer spell of dry weather or drought takes hold. So humans do try to control them with pesticides, burning, GPS tracking nowadays, various other means. Obviously, pesticides can be problematic. There are some biological controls that they've been experimenting with that have been somewhat successful, which is a little, in some ways, safer. But, obviously those have their own issues too. But anyway,
right.
It's a big problem. It'll continue to be a problem, almost certainly. As an interesting side note, I'm going to end on this. Locusts are actually eaten in many cultures, and they are the only kind of insect that are considered kosher under Jewish dietary law.
Nice.
Yeah.
Cool.
I like it. I think that's probably a holdover of when I remember my Old Testament at all. From the plagues that happened. Probably a grudge.
A grudge.
I'm going to eat you.
That's what it is.
Yeah.
How many dietary practices in the world are based on grudges?
At least one.
All right. And that's what we have for today. Thanks, everybody. We will talk to you next week.
Thanks, everyone.
Bye. Thanks, everyone, for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.